Aloha Alge 2. Today we are chapter 6, right? We're going to bust out our notes and we are on the last section of chapter 6. We're going to have a big bad boy test coming up pretty soon. The nicest thing about the last piece of this section in terms of chapter 6 is that it's going to be very familiar to us because once again, we are graphing, okay? So we're graphing radical functions. Now, in this particular chapter, since it's Algebra 2, the only one you need to be concerned with is our square root function. Okay, those are the ones we are going to graph. So if you look right here, okay, our square root function, correct, is going to be y equals the square root of x. And we all know, if we can remember correctly, we all remember what a negative sign does in front. Remember, that would be a reflection, a vertical reflection over the x-axis. Okay, which would be this guy right here. If there's a number out in front like that, remember it would be a shrink or a stretch. Okay, if the number is bigger than 1, it's going to be a stretch. If the number is between 0 and 1, it's going to be a shrink. And then remember, in this format right here, depending on what h and k is, we are going to, h tells us if we go left and right, and k tells us if we go up and down. Remember, when we did those things, we called those guys the Rst method, which stands for reflection, stretches and shrinks, and then translations. So when we graph square root functions, we're going to go along that same process, okay? So we're just going to do some examples here together. Guys? All right, here we go. Number 1. Let's do y equals the, let's go 2 times the square root. Once again, I said we're going to just stick with the square roots. X minus 3, and then let's go with a plus 4. Okay, and so remember, whenever we're graphing in this class, in this unit Algebra 2, even going to pre-calculus next year, a great way to do these graphs is we do RST. Now, when able to do RST, our reflection, stretches, and shrinks, and translations, we need to know what our parent function is. Okay, and for this particular problem right here, our parent function, okay, and I'm going to do it over here. Okay, so make sure you put this in your notes. Our parent function for a square root, and what it is we want the most basic square root function that we can, which is y equals the square root of x. Now, just like always, we want a table of values to get this guy graph. Okay, and what would I choose if it was a square root? Remember, there's a 2 in here. And if there's a 2 in here, I can't have any negatives. So I can't choose any negatives for x. So a lot of you will probably say, hey, let's start with 0. And 0 would be a great option because the square root of 0 is 0. And then some of you guys might say 1 is a great option. It is, because the square root of 1 is 1. Now, if I don't have a calculator, 2 would not be a good option. Why would 2 not be a good option? Because square root of 2, what the heck is that? That's actually like 1.4. And you wouldn't want to graph something like that. That's crazy talk. What about the square root of 3? Do you guys know what that is? It's about 1.7. But once again, crazy talk. That's not very good. So the next good number we should choose is 4. Why? Because the square root of 4 is Niban. Okay, it is 2. And believe it or not, that's all you need to get a good graph. If you want to think of what the next good value to pick would be, can you guys figure it out at home? It would be a 9er, because the square root of 9 is 3. Okay, and if we graph this guy, it is going to look like this: 0, 0, 1, 1, 4, 2. So this is our parent function right here in blue. Okay, and if I could even go 9, 3, right, it'd be like over here somewhere. Okay, it continually gets bigger. However, it gets big really, really slow. Not like our exponential function that like gets big really, really fast. And it's important to pay attention to 2 things here. What is the domain of this? Do all the x's work? Can I put all of the x's in there? No, I can't. I've got to start at 0. But then it can take any positive number in the world, right? Okay, and what about range? Range, remember, deals with the y's. What's the smallest y value here? Well, guess what? The square root of 0 was what, class? It was 0. And it goes high for, doesn't look like it goes high forever and ever, but this dude does actually continue to go up forever. It's going to continue to go up forever, ever, ever. All right, so now we're going to go ahead and we're going to graph with RST. Now, how do we graph with RST? Remember, the way we graph with RST is we write down R, S, and T. Okay, and the first thing we say is there a reflection? And you're going to say no vertical reflection. And remember to write all that out, okay? And it would be over the x-axis. Okay, why no vertical reflection? Because there's no negative on the outside. Remember, anything that's on the outside will affect it vertically. That 2 is on the outside, but it's 2 times. So that's going to be a vertical stretch. Why is it a vertical stretch? Because that number is bigger than 1. So that is a vertical stretch by dos ni ban. All right, and then last is translation, that 3 on the inside. Remember, we kind of always say we do the opposite. So that's going to be to the left 3. What? We do the opposite, I said, right? So it's going to be to the right 3. Okay, and that 4 on the outside means up 4. We do exactly what it says. It's on the outside. On the inside, remember, we kind of like to think of it as we do the opposite. All right, and then what we need is we need table of values to get us going. Here we go, x, y. Now remember, there was no vertical reflection. So I start with the same values as the parent function, right? You're going to use these guys all the time, every time, okay? And then what do we got? We got a stretch or a shrink. And we stretch it by 2. Remember, it's vertical. So if it's vertical, that means we change all of the y's by 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 4. So it stretches it a little bit, okay? And then last, we translate x, y. Right 3 means we add a 3 to all of the x's. 0, that's at 0 right there. Plus 3 is 3. 1 plus 3 is 4. 4 plus 3 is 7. All right, that's 7 in French. And then we go to the 4. 0 plus 4 is 4. 2 plus 4 is 6. 4 plus 4 is 8. And then, believe it or not, we just have to graph it. And we just have to make sure that my graph looks like this guy right here. Okay, it's got to look like that guy. So it's 3 count for 1, 2, 3. 1, 2, 3, 4. Okay, spling. 4, 6. 4, spling. Ooh, it's stretching. 5, 6, 7, and then 8. 8 would be about up there. So it's stretched, but it's going to look the same. Very important to know that since this was the starting point, right? That's the starting point. The top guy, that means this top guy is always going to be the starting point. Okay? That's the starting point. And that point of 3, 4 really helps us out with domain and range. For this particular problem, my domain would be 3 and bigger, right? It's whatever the x is. Tree. And the range, believe it or not, is going to be whatever the y is. And it goes up. So it's going to be infinity. It's important to know because we'll ask domain and range questions. Now, I definitely do not want to erase all of this because I want my my parent function there. We're going to do one more together, you guys, and then that's it. We call it a day. That's chapter 5. Make sure you're reviewing like crazy. What's the best part about flipping the classroom is that any type of problem, let's say you're not doing well with section 6.2 and 6.3, then you can go back and watch the videos, right? It's the best job of flipping the classroom, best opportunity with flipping to the classroom. Or what I would say that you guys could do that would even be better than all of that stuff is come in for some help. All right, and come in the mornings, say after school when I am available, and we will help you guys dominate the next test. All right, here we go. Last problem we're doing today, number 2. And then remember, make sure you try some of these guys on your own. Let's go y equals, I'm going to have a little bit of a lag going on. -3 square root, okay, let's go x plus 2. And then let's go, I'm going to leave nothing on the end. What the heck would it mean if I left nothing on the end? Well, let's see how that happens. All right, now we already have the parent function. Ooh, I've got a little lag here, so stay with me, class, all right? So we're going to go to Rst. Now, there definitely is a vertical reflection. Why is there a vertical reflection? Because, sorry, guys. So there's a vertical reflection over, what? The x-axis. Got a little bit of lag going on. Okay? All right. But we're going to bear with it. We're going to get through this bad boy too. There definitely is a vertical stretch. Why? Because there's a number on the outside. It's 3 times. So that'd be a vertical. And remember, if that number is still bigger than 1 because we have already taken care of the negative sign. So if you want to think of absolute value, go ahead and think of absolute value. But we would say it's a vertical stretch by 3. Stretch because 3 is bigger. Okay, then 1, and remember, it's just that number. The negative we already took care of with the vertical reflection. And then translation, that's a 2, but it's x plus 2. And when it's horizontally affecting it left and right, we do the opposite. So that would mean left 2 And then, oh snap, there's nothing here on the outside. Some students like to add a plus 0. So that would mean 0 up or down, right? So we don't even have to write anything there. And then what do? We do our little table of values. Okay, now this says it's a vertical reflection. So if there's a vertical reflection, what would that mean? That would mean I would take my parent function and I would change all of the y's, because it's vertical and vertical affects the y's. I would change all of them and make them negative. So that 0 turns negative, which means nothing. 1 turns negative, only the y, and the 2 becomes negative, only the y. Okay, and then we go to our stretch, and our stretch was by 3. So we're going to stretch this bad boy by 3. And remember, for these guys, this is my starting point, right? So it's still 0, 0, still my starting point. 1, -3, and 4, -6. Okay, then we go to translation. And then this means 2 to the left. So what would that mean, 2 to the left? Well, I'm going to subtract 2 from all of these x's. So it's -2, -1, and 2. And guess what I'm going to do to the y's? It was 0. So if it's 0, I'm not going to change any of the y's. And then I'm going to graph this bad boy. -2, 0 means it's smack dab right there. That is my starting point. Very important to pay attention to. Because remember, this was my graph of the parent function. And since there's a reflection, instead of going up, it's going to go down. Okay, and I have to make sure I pay attention to that. We have -1, -3. Okay, it is stretched, but it's going down. Very important to make sure you pay attention to that. And then that guy's at 2, -6. And a lot of students struggle with this. It's got to stay with this shape. But instead of going up, it's going to go down. Okay, so that's exactly that's my starting point, remember? And it's going to go down. And you do have to show that this guy will flatten out. Okay, and I've got that lab. So probably not the best graph ever. But the question is can you do the domain and the range? Remember, what helps us with the domain and range in these problems? Well, the starting point does. That's -2, 0. So the x is -2. But if I look at the x's, it starts at -2, and the x's go this way, right? The x's go that way. So it's -2 to infinity. But when I look at the y's do have a 0 there. But guess what? That 0 is the biggest y on the entire graph. Why is that the biggest y on the entire graph? Because the graph goes down. So remember, we always have to put the bigger guy second and the smaller guy first. So what's the smaller guy if it always goes down? You got it. It's -infinity. Always a parentheses there, and since I color in that dot there, it's got to be a bracket there. All right, that's graphing radical functions, equations. Hopefully you guys felt good about it. Make sure you come in for some extra help if you need it. Make sure you guys are going back and looking at previous lessons if you guys need help with those lessons. All right? Remember, you can come. I'll show you right here. You guys can come right here to my website. Go to Chapter 6. Remember, you've got all of these videos right there. Go back and watch whatever ones you guys need help with. All right? Aloha. Study up for that test.